Finite series. The sum of a finite arithmetic series has a specific formula. That formula is S sub n equals n over 2 times a sub 1 plus a sub n. Alright, so now if we apply that formula to this first one, we need to first think what we're even looking at. What this means is the sum. The symbol like that means summation. So it means you add everything up inside of there. Okay, so if we were trying to add all the things up inside of there, that means we're going to take a sub 1, add it to a sub 2, plus a sub 3, and so on, all the way to a sub 9, and then that's our final answer. But if we apply the formula we just put in, then my a sub 1 term is equal to 2 times 1 minus 1, and that number would be 2 minus 1, which is 1. So a sub 1 equals 1, and then we want to find our nth term. Well, my nth term is 9, because that is where I'm stopping, at the 9. So a sub 9 equals 2 times 9 minus 1. 2 times 9 is 18. 18 minus 1 is 17. Now if I actually apply the formula, S sub 9, the sum of the first 9 terms, is equal to 9 over 2 times a sub 1, which is 1, plus a sub 9, which is 17. So that means I have 9 over 2 times 18, which is 81. So S sub 9, the sum of the first 9 terms, is 81. For this next example, we have the summation from I equal 1 to 7 of negative 3i plus 5. So again, we want to find my a sub 1, which would be negative 3 times 1 plus 5. Negative 3 times 1 is negative 3. Negative 3 plus 5 is a positive 2. And then I want to find my a sub 7 because my highest number is 7. So a sub 7 is equal to negative 3 times 7 plus 5. Negative 3 times 7 is negative 21. And negative 21 plus 5 is a negative 16. So if I put that into my formula, S sub 7 equals my 7 over 2 times my a sub 1, which is 2, plus my a sub 7, which is negative 16. So that's going to give me 7 over 2 times negative 14. So that's going to give me a negative 49 as my final answer. So S sub 7 equals negative 49. Final answer. Geometric series is a little bit different. The sum of a finite geometric series is going to be S sub n equals the summation of I equals 0 to n. It will be of that form of a sub 1 times r to the I power, or that is also the summation of I equals 1 to n of a sub 1 times r to the power of I minus 1. Those are the same things. Or we can simplify it and generalize it to a sub 1 times 1 minus r to the n power divided by 1 minus r. And that would be the formula that you're going to use. So let's apply that to this first example. So we have the summation of I equals 0 to 12 of 4 times 3 to the I power. So it's of this form right here, where the I equals 0. So that means we can still find it the same way. If we find our a sub 1, a sub 1 is going to be the thing multiplied on the outside, which in this case is 4. So a sub 1 is 4, My r is the thing that is the base of the exponent, which in this case is the 3. So now if I put that in, s sub 12 is equal to my a sub 1, which is 4, times 1 minus r, which is 3, to the power of n, which is 12, divided by 1 minus 3. Alright, so now when I actually go ahead and start working this out, what I would get would be 4 times a negative 531,440 divided by a negative 2. So then if you go ahead and simplify, 4 times 265,720. And your final answer, the sum of the first 12 terms of this geometric series, would be 1,062,880. In this last example, we are looking for the summation of all I equal 1 to 7 of 2 to the power of I minus 1. So this is of the other form, but it's the same thing. So whatever is before the exponent, the power, which in this case is a 1. So because it's a 1, then that means a sub 1 equals 1. Or you could actually put in 1 and find that out. And then my r is the base of the exponent, which is 2. And then I put it into my formula, which would be my 1, s sub 7 equals 1 times 1 minus 2 to the 7th power divided by 1 minus 2. So that's going to equal 1 minus 2 to the 7th power is actually going to be a negative 127 over 1 minus 2, which is a negative 1. So that means that s sub 7 is equal to a positive 127. Final answer. So those are your notes over finite series and how to implement summation on finite series. Go through the practice problems, make sure that you understand the different forms and can do them both, and then prepare for your quiz.